Hello students, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning one of the important topic in fault tolerance in distributed systems, that is reliable client-server communication in distributed systems. So let us begin. So when we say that the communication between the client and server is reliable, so whenever the sent data is received properly by the client and the server, then we can say that the communication between the client and the server is a reliable communication. So this communication that takes place between the client and server uses two protocols, that is TCP/IP protocol and RPC protocol, that is remote procedure control protocol. Then in addition to the process failure, communication channels can also fail. And these are the failure types that are exhibited in process as well as the communication channels. So which are the failure types? Crash failure, omission failure, timing failure, and arbitrary failures. So in practice, whenever we want to build a reliable communication channel, the focus is on masking crash and omission failures. Arbitrary failures may occur in the form of duplicate messages, resulting from the fact that in a computer network messages may be buffered or relatively long time and are re-injected into the network after the original sender has already issued a transmission. So here, as I've told you earlier, the TCP/IP and RPC communication protocols are used in the communication between client and server in distributed systems. This TCP/IP can mask the omission failures. However, it cannot mask the crash failures. Okay. Now, the solution to this omission failure is retransmission or sending an acknowledgement. But to mask crash failures, we can automatically re-establish connection. So let us say this is a client and this is a server. So it is sending a request to the server, let's say in 2 seconds, and it is sending a reply saying that the server is down, please resend it. So this is again, client is again sending the message. Again server is saying that I am down, please resend it. But this sending and resending, this all is hidden from the user. So it is automatically, the client is automatically sending the request of connecting to the server, and accordingly if it is up and live, the server is up and live, it will get connected. Otherwise it will send an acknowledgement saying that again you can resend the or re-establish the connection. So there are 5 classes in failure of RPC. So this RPC mechanism we have seen in the earlier lecture that it works in client and server perfect. Now there are 5 classes of RPC failure. Which are those? The client cannot locate the server. The client's request to the server is lost. The server crashes after receiving the request. The server's request is lost on its way to the client. The client crashes after sending its request. Now let us see all this one by one. The first one is client cannot locate the server. Now the solution to is exception handling. Now what it is, let us see that. So client will send a request to the server. Now after sending the request, the server has failed or it has gone crashed. Now client is expecting the response from the server, let's say within 15 seconds. It has set a timer to it and it expects a response from the server within 50 seconds. However, the server is not able to respond because it has got crashed. So in this case, the RPC will raise exception handling messages. These exception handling messages will be like the page cannot be reached, server is not responding likewise. So this is the solution for whenever a client cannot locate the server. Just send the exception handling messages. Then the second one is lost request messages. So here lost request messages means whichever request has been sent by the client has lost. So the solution is using acknowledgement and timer concept. So what is it is, so the client, and there are client and server, client is sending a request. So lost request message. Now the request is not able to reach the server and it has got lost in between while transmission. Now again there is a timer of 50 seconds. Now client says that it is expected that I should receive a response within 15 seconds. But if the server has not received the request, how it can send reply or acknowledgement? So the server will not send the reply or acknowledgement. Then a client identifies that maybe the request has lost, or maybe server has got down. So let's retransmit. So after 50 seconds, after waiting for 50 seconds, if it has not received a reply or an acknowledgement, it retransmits the request. This is lost request message. The third one is, before going to the third one, the advantage of lost request message is that server will never know that the packets are retransmitted. The server will never know that the client, the request has lost, or maybe they are retransmitted. So this is one of the advantage. Now moving to the third one, that is server crashes. So the server, at the server side there are three cases. Initially, a client will send a request to the server will receive it, execute it, and accordingly it will reply to the client. This is how successfully done. Then whenever a crash happens after execution, so request is sent to the server will receive the request, it will execute, and now crash happens. So in that case there will be no reply given. Again, the third case is that request is sent to the server, server receives the request, but here crash has happened before service is executed. In that again, in this case again, there is no reply sent to the client. So depending on the case of the crash, the operation that server should perform will vary. Now in this case, as execution is done, only retransmitting the reply will resolve the issue. So whatever request has been was sent, it has been executed. So just retransmitting the reply will solve an issue. But in this case, here after receiving the request, the request was not executed and the server got crashed. In that case, there is we have to send the request one more time. So request has to be sent one more time by the client because it was not executed. So here, so there are remote operations. Let us consider this scenario wherein there is printing some text. Then after printing, send a completion message is some another activity test to do. So there are three events that has to be performed. So the three events are send the completion message, which is M, send the print text, that is P, which is denoted by P, and crash, that is server has got crashed, that is denoted by C. Now based on these three events, 6 different orderings can happen. So here if you see, there are certain events that are mentioned into the bracket. This suggests that these events have occurred after the crash has taken place. So here if we see MPC, that means the message was sent, the printing was done, and then the server got crashed. Here in the second case, a message was sent, completion message was sent, then server got crashed, and then in bracket if you see there is printing of the text. So here after crash, this particular operation could not be performed. So whichever is there in the bracket, this cannot be performed. Similarly, look at the sixth operation, that is C, and M and P both are in bracket. That means nothing has happened because before performing these activities only the server got crashed. Then this server crashes are dealt with 4 of the possible implementation philosophies, that is at most once, at least once, and exactly once semantics. And the last one is no semantics. So here at least once means what? So the messages will be pulled once. So there is possibility of receiving the message or not receiving the message. There is possibility that the message will received by the server or not. Here in the second one, that is at least once means what? Message will be pulled one or more than one. So it is so the receipt is guaranteed, and obviously when the message is sent more times, then there can be likely of duplications. And every time the message is pulled, it is processed. Exactly once means what? So message will pulled only one or more times, and but the process, it will be processing only once. Here receipt is guaranteed, obviously no duplicates and no missing data. And the last one is no semantics, which means nothing is guaranteed. Neither clients nor servers take their chances. The fourth one is lost reply messages. Now, this lost reply messages means what? So, are difficult to deal with. What are difficult to deal with? Lost reply messages. Why? Because we are not able to understand the reason of why the messages has not been receiving. So maybe the server is dead, or maybe it is slow. So sometimes what happens is that, let us say, consider a scenario or an example wherein if I want to fetch first 1024 bytes repetitively. So if I'm performing this operation 9 times, 10 times, 12 times, I'm able to get first 1024 bytes always if I perform the operations repeatedly, and there is no harm, or it will not cause any damage. So this type of a request which has this property is called as an idempotent. So what type of a property? If same operation is performed repetitively, it is not going to cause any damage or harm. So these types of operations are called as idempotent. But wherein the operations, such as if I'm performing some bank transaction, initially I sent a mail or sent a request of withdrawing of 1 lakh rupees, and later that message got lost and I retransmitted the message, and by that time server got that message, earlier message, but the second message was retransmitted. Again the request for 1 lakh rupees got transmitted. Ideally it was to be transferred only 1 lakh rupees, but now because of repetitive task it caused damage to the account, and in place of 2 lakhs got withdrawn. So these repetitive tasks are called as non-idempotent requests. So certain operations which perform repetitively will cause damage are called as non-idempotent message. So what is the solution to that? So the solution is that one way is to structure all requests in idempotent way, which is highly impossible. Then the second one is giving the unique sequence number to all the clients, and the third one is that to the header of a particular message, just add one field which says that whether the message is initial or whether it has been retransmitted, and accordingly then operation will be performed. And the last one is client crashes. So what happens here is that client sends a request to the server, server sends the reply accordingly, but then reply is not received to the client because client got crashed. So the reply which is executed and which needs to be sent to the client, that particular client has only got lost, or it has got killed, or it has got crashed. In that case, no parent of this particular reply is waiting. So this particular type of a message or reply is unwanted now, because its parent who initiated that request for which reply has been created has killed. So that particular computation is called as an orphan message. So 4 orphan message solutions are there, that is extermination. So wherein a client keeps a log entry of all the RPC message, and this RPC message log is kept on a disk which survives the crash. Now let's say the client got rebooted. Now when the client got rebooted, it will check the log, and now in the log if there are orphan messages, then that orphan messages will be killed. The second one is reincarnation. What is reincarnation? Client sends new epoch number to the all the computers, and whichever are the remote computations will be killed. Then the third one is gentle reincarnation. So here, whenever the client sends a new epoch number, it will locate the owners, and if there are no owners, then it will kill those computations. And the last one is expiration. So if the result is not returned in a specified time, then it is assumed that it has been expired. So thank you for watching the video. If you have any doubts, please do post in the comment box. Thank you everyone.